Many people get into software development or front-end development without a computer science degree, myself included. It took me quite a few years to get into collections, to see and feel the usefulness. Beyond just having an array or an object, there's so much more out there. Collections might be a gap in your knowledge as well, or you might be just starting out with JavaScript and simply haven't taken the time to look at them yet. And if you're unfamiliar with them, you might be missing out on nice language features, or you might have trouble solving certain kinds of problems. Let's look at collections. JavaScript has 4 built-in data structures, and there's also 3 conceptual collections you can make with these built-ins. I'll first talk about the built-ins, then I'll move to the stack, queue, and Deque, because they're very similar and they're sort of their own group. Graphs could also be considered a collection, but I'll not talk about them in this video because they're a very complex, big topic, and they're also not available in the standard library. Maybe in a future video, let me know in the comments if you would like to see that. To determine which collection, which data structure I want to use, I ask myself 3 questions. The first question is split up into a sort of sub-question. Do I want to access only the first or the last part of a list of items? Or do I want to think of my collection of elements as a function? Namely, if I give it an input, I want a certain output, which is the key value store that we often see, which is an object versus an array. The first 2 most obvious collections are of course an array and an object, and the object is accessed by its keys. You can access any random value, it's called random access, in that store. It doesn't matter where it is located. But with an array, you have to know a specific index. So there it's not about key value, it's more about you have values. They just happen to be indexed. But if you want to grab the last or the first item and you don't know what that item is, you can just ask for that. The array has the functionality to give me the first or last item. The object does not have such a thing. The object is unordered. This is the way we need to think about collections. First, let's take a look at array. An array is ordered, it is indexed, and it supports duplicate values. It is indexed in the sense that it has numbers to access the items in the array from. It is not a key value store. Now in this video I'm talking about collections. I'm not talking about a specific way in JavaScript that an array is also an object and you could technically attach properties and misuse it as a key value store, but that's not the intention behind an array. That's not what's relevant for collections. So I'm going to ignore that fact for this video. Arrays are of course also known as lists, and they have a specific way, they have syntax in JavaScript. To create an array, you can use the square bracket syntax. They have easy access, you can request the size easily. They request the random access is possible, so you can access any element in the array at whatever point in time if you know its index. Iterating an array is easy. You have map and for each, which both run a function for each element in the array. There's the for of construct. You can even use a old style for if you want to let e is 0, e is smaller than the array.length, stuff like that. But that's the old way of iterating an array, and I would certainly not recommend using it nowadays. It has various ways of mutation available. You can update any index, again if you know its index. Then there's the 4 methods that will be explained later on this video, because they're stack, queue, and Deque methods, where you can add at the beginning and at the end, and remove at the beginning and at the end. Where you don't know its index, you don't need to know the length of the array, but you can still ask it for the first or the last item. And lastly, conversion. Moving between different data structures such as an array and an object is quite easy, but you do have to realize there are 2 different structures. An array is just a list of items, and an object is a key value store. So the moment you want to move from an object to an array, you are losing information. You will, for example, have to generate a 2-dimensional array, or you will have to generate an array of only the values and thereby losing the keys. This is fine sometimes, but you do have to be aware that they're conceptually different things. Next, let's look at objects. Objects are not ordered, they're key value pairs, they allow duplicates, and the keys have to be strings. So they're very different from arrays. Because they're key value pairs, they allow for a different type of access. And this was the first question I mentioned earlier. If you need random access somewhere in the middle of whatever your collection is, then an object allows you this. By knowing its key, you can simply access the value. So it almost works like a function. You have an input and an output, and this is the way you would naturally use an object. Yes, you can iterate it by converting it to an array or something like that, but that's not the usual way of accessing objects. Let's look at a few properties. Size is an interesting thing. Yes, you can get the size of an object, but it is not the intentional way of using an object. If you need a list, then an array is better if you want to compute its size, or a set in that case. But an object, you have to decide, because it supports all kinds of inheritance via, for example, the prototype chain. You need to tell it, I only want my own, so get me my own property names, which is also conversion to array. Then you can compute the length of that, because again, an object itself doesn't have a length. You need to do something with it, like conversion to an array, to be able to get the length. So yes, it's harder, it's possible, but it's not natural most of the time. Random access, very easy. This is what objects are optimized for. So if you know a key name, then you can easily get its value. This is what they're for. They're also known as maps, dictionaries, associative arrays, associative collections, lookup table, hash, just hash table or hash map. There's many different names, and all of these are sort of similar, sort of the same. Some of these are literally the same. They have slightly subtle definitions, but I will count them as one, because an object supports, the JavaScript object supports multiple ways of using it. Iteration is again possible, but slightly unnatural, because you have to decide how you want to iterate over it. It has a keys, values, and entries method. Keys gives you an array of the keys, values an array of the values, and entries a two-dimensional array, which has both the keys and the values in there. Yes, it is usable, and yes, because it is an array, after that you can use it in a statement like for of, which is a really nice way of using it, but you have to basically convert it to an array first before you can iterate it. So in short, the answer is no, you cannot iterate an object directly. You need to first convert it. Mutation is easy if it is random access. Then you can, if you know its key, you can simply add or change or delete a specific key value pair. Converting between arrays and objects is also relatively simple, but you again have to decide whether you want loss of information here. As I've shown with the array example before, if you have an array and you want to create an object from that, then you will have to invent keys. And since objects have string keys by definition, they cannot have any other type of key. An array must have an integer and an object must have a string. That means that for converting an array to an object, you will invent keys that are numbers represented as strings, which is again a bit odd, but it makes sense because they're conceptually different things. If you look at the example I gave here, anything that is a key value store, when you are working with random access and order doesn't matter, is a very good use case for objects. They're literally a different use case from arrays. If you want to have ordered things, if you don't care about keys, if you don't need random access, arrays are a very good use case. This is really a different thing. Next, set. Set is an ordered list of values that have to be unique values. So there's no key value pair. Set is analogous to an array, not an object. Set can be created quite easily. You can either give it an array to make a set from, or you can call the add method several times. Access is relatively easy. You can access the size property, and you have a has method available, which will give you a boolean whether the value that you specify is there or not. Again, you cannot randomly access an item here. A set is not intended to answer the question like, can I get the second item? Can I get the seventh item? Can I get the item at that index? That is not what a set is about. A set is only a list, like an array, but you cannot access the items at their index. Iteration is done via for each or a for of. Both are possible, and the mutation methods are add, delete, and clear. The second time you try to add another value, because it is a unique data structure, it will simply not execute that operation. Deletion is again by value, not by key, and you have a method for clearing the whole set, emptying the whole thing. Converting from a set, we've seen the array example. You can also convert the other way around. From a set to an array gives you the values. Moving from a set to an object, you would need to invent keys, because objects of course require keys, and the other way around, you would lose keys. You would in this example, I picked the values method, give me the values of this object, and then I can create a set from it. Directly from an object to a set is not possible. You have to first make an array somehow, and by the conversion of object to array, you would lose the keys already. Since set is modeled after the mathematical set construct, there's a bunch of operations, set operations available you can run on a set. Yes, you can also run them on an array, but since set is unique, they're supposed to be run on a set. I have 4 operations implemented here. I haven't implemented these myself, they're just on the Mozilla Developer Network documentation. Superset, this will yield true if all the elements in B are also in A. Union is merging 2 sets together, but since sets are unique, you will only get a set that has the unique elements. There can be no duplicates. Intersection is only elements that are in both sets will be returned as a new set, so it's sort of the overlap. And difference can be thought of as set subtraction. So this call will return all the elements that are in A but not in B. Now these implementations I just plucked from MDN available there. They're very simple implementations. There's just a few lines of code. Sets are very useful when you need a list of unique elements or when you need these kind of operations. Yes, these functions are also available in something like Ramda or Lodash, but there they operate only on an array. So you cannot, in the language, guarantee uniqueness. You have to rely on a function from a library. Next, let's look at map. Map is ordered and key value pairs. So it's somewhere in the middle between an array and an object. An object has key value pairs and an array is ordered, but an object is not ordered. And an array does not have key value pairs. A map is both. It is different from an object in a way that keys can be of any type. A key of an object has to be a string. A key of a map can be anything. It can be another object, for example, which is one of the big use cases. Map is created by giving it a 2-dimensional array, or you can call the set function multiple times, but if you are converting from another object or data set, this is usually the way. The pairs, an array of pairs, the pairs are the key and the value that you specify. You can get a size from a map, you can see whether a key exists and therefore has a value, and you can get the value for that as well. Iteration is done again via converting to an array, which is similar to what goes for an object, because objects and maps are sort of similar. They have both they're both key value stores, and therefore, if you want to iterate them, you have to convert to an array first. You have to determine what do you want to iterate. The keys, the values, a 2-dimensional construct of both the keys and the values. And once you have made that decision via one of these calls, then you can start iterating it. But after the conversion, you're, of course, technically iterating an array. Mutation, the set operation for setting a specific value for a specific key. If it would override it if it exists, and it would add it if it doesn't exist. And you can delete a key value pair by giving its key and a delete, and you can clear it just like with the set. When converting, you have to deal with again, what information do you want to lose or create? When you're creating a new map, just like with the example above here, from an array, and you need to have a 2-dimensional array to create a map from it because you need to have keys available. If you want to go from a map to an array, that's okay, but you will get a 2-dimensional array because it will also have keys, not just values, unless you start calling the values method and you choose to ignore the keys. If you want to go through an object, that's easier. You will still go through an array because there's no literal conversion available. Object entries is, again, creating the 2-dimensional array here, and then you can create a map from it, and the other way around. Entries is, again, the 2-dimensional array. So when do you use a map? When is a map natural? I have 2 examples to answer that question. First, anything that has a key value store is potentially a map, but why would you want to use a map over an object? Because we have a more simple key value store, of course, the object. So when do you want to upgrade towards using a map? One example is if you want to have a collection that is ordered, an object is not ordered, or you want to add other properties to that object, but you don't want to mutate the original object. Say I have some data store, a bunch of users here, and I want to be able to iterate them. This iteration example looks very simple, but the difference here is that if you would iterate over an object, the order is not guaranteed. It's literally not guaranteed. You could get a different order, and not for each call, but it is an unpredictable order. So the moment you start running for off on something that is not a map, something that is an array, it is also fine because that is ordered. But if you use an object that is unordered, you don't know what order you're going to get. If you need your data to be ordered, and it is also of the format key value, then you would use a map. So this is a very simple example. You can get random access here, but you can iterate them in order. This is a predictable order. The order of insertion, not guaranteed in this example, because I've made a mistake here. This is a very common mistake. You're creating an object, which you then convert into an array, which you then create a map from. Now, the order is guaranteed inside the map, but the order is not guaranteed inside this object here. In this example, I've rewritten it to be 3 different set calls. So this same order is now guaranteed for all the iteration, for example, of the for of. In the previous example, I had the bug in my code that since I was casting to an array and then to an object and then to a map, you are losing the information when converting to an object, because when you store it in an object, the order is not guaranteed anymore. Another common way to solve this specific problem is to add an order property to these objects and then still use an array of objects or something like that. But then you would have separate steps to sort this array of objects, or you would have an object of objects which then has a property and you need to sort it on. This gets messy really fast. Order properties in this sense it's probably less efficient than using just a map. Another good usage example for using a map over an object is when you need keys that are not strings, for example, that are objects. This is one of the common use cases for map. Say I have this user's data, it's an object now which contains other objects in there. So it's sort of a list, it's a collection of users. I want to access them by their user ID, but I also want to store some more information. For example, I am an admin, so I need to store this admin to this specific user. But since maybe I'm in a context where I want this to be immutable, I don't want to change these objects. I don't want to mutate these objects. So I can create a map with additional user info and use the object itself as a key. If I would have an object that I want to attach more information to, additional information to, this is the way to do it. And you can then merge these objects together into a new object if you want a combined object with all this data together. And this is actually a good example for weak map. When you would delete the users from the user's object, the matching user would also be deleted from user's additional object, because this is a reference to an object and weak map only stores weak references. So if this object gets garbage collected because it goes out of scope or something like that, it would also be automatically deleted here. Weak map and weak set have more use cases, but we would have to get into the rather large topic of garbage collection. So that's a bit long for this video. The next 3 I want to talk about is the stack, queue, and the Deque. They're all very similar data structures. They're plain lists, so to say, that have, they're not key value, they have an order, and they have a single way of accessing and removing items. It's either at the front or at the back. There's no way to access an item in the middle, and the power is in the limitation. This makes them, by definition, based on an array or a set, and never an object or a map, because those are key valued, an object isn't even ordered, and a map supports random access, which is also not what this is about. The difference between these 3, the stack, the queue, and the Deque, is where you add and remove items. Is it at the beginning or is it at the end? Or is it at both? This limitation for the first 2 data structures, the stack and the queue, expresses itself mostly through having only 3 operations: add, remove, and peek. If you implement a stack, queue, or Deque with an array, it would support duplicate items, of course. If you implement it with a set, you would have unique values only. Let's talk about a stack first. A stack is most easily implemented with an array. We have push and pop methods which add at the end and remove from the end. You can think of a stack as a stack of plates. You can add one to the top and you can remove one from the top, but it is very difficult, and in this implementation impossible, to get a plate from the bottom of the stack. That is not what a stack is for. The array has push methods, it has pop methods, and you can indirectly peek at what the current item is, what the next item is, which you would pop off if that's what you want. And these are the 3 ways to do this in native JavaScript. You can of course implement it as your own class, which has these 3 literal methods like add, remove, and peek. And you can also implement it with a set, which I've done here. This is a basic class which stores the stack as an internal set, which is created upon constructing it, and it has push, pop, and peek as methods, and the moment you push multiple on, the second one will be a no operation. It will be a duplicate, so it is a unique stack in this case, so it will disallow that operation. And the pop method converts to an array so that it is able to give you the last element that was added, which is not a feature that the stack data structure has on itself, so you have to convert it to an array first. This is done with a array from call, which will give you an array which has a pop method. The array was mutated and is then converted into another set so that the state is updated and the value is returned. For peek, it is just looking at the last value, and that's enough. So this is a way to implement a unique stack with a set backing it. You don't need this very often, but it's possible, and there's also ways of implementing a stack with just a class so that you have the push and the pop methods available if you only want the native array functionality, so to say, but you don't want the random access capability of the array. You want to limit the user from doing this, which is a good reason. And if you would implement it like this, this is what it would look like. I have only the push, pop, and peek methods, which are the ways you would implement this with an array from my first example. The one I have here is the same code, only in a class. But in this case, you are not allowed to access, for example, the third index directly anymore. It doesn't support array access, so you're limiting the user here, which in this case is allowed. Stacks are very useful for anything that you want to access in reverse. You want to store it in one way and then access it reverse. An example of this is storing the undo history in an interface that the user has done all kinds of actions. The moment they start undoing, they want to start at the end and reverse these actions in order. Stacks are also called LIFO queues, last in, first out queues. Let's talk about queues, which are FIFO queues, first in, first out queues. The implementation of a queue is very similar. It can be implemented with any data structure that supports adding to the end and removing from the beginning. But the order of a queue doesn't really matter. You can flip it also and add at the start and remove at the end. It doesn't really matter. There's in arrays 2 ways of doing it because these methods are all native: push, shift, unshift, and pop. So running a queue can be done in these 2 different ways, front to back and back to front. And of course you can have a unique queue as well. You can back it by a set instead of an array if you would want to. That's a similar implementation as the one you've seen before with the unique stack. I'll leave that as an exercise to you. Queues are generally useful for many things. If you want to access the data or process some data in the same way it was stored, a queue is your friend. If you have 2 different classes or modules that are processing some data, one could be, instead of calling and tight coupling itself to the other module, it could push items onto a queue, and the second module or class could pop things from the queue and process it. So they're both coupling themselves to a generic data structure, which is loose coupling towards each other, which is a nicer way to structure your code. So queues have a very broad usage. And lastly, a Deque. A Deque is a combination of a stack and a queue, and the DE stands for double-ended, so it's a double-ended queue. It is an ordered list that supports adding items to both ends of the queue and removing from both ends of the queue. And this is again very easy to implement because we have these methods available already. The example I have here is with an array, you have again the unshift and the push methods for adding at the start and at the end, and you have the shift and pop methods for removing at the start and removing at the end. So you as a user can pick where you want to add and remove. Deque can also be implemented with set, of course. Same exercise for the reader here. It's very similar. You would convert to an array each time you need to access it because set doesn't have the capability of array access at the beginning and the end. There's some use cases available like a stack or a queue with a maximum size. You would always add items at the front and remove them from the back, but the moment you have the queue has become too long, you would start removing items from either the front or the back depending on priority. And that's it. I hope this was helpful. If you have any thoughts or requests for things you'd like to see, leave a comment and subscribe. Thank you very much for watching.